Hey there. So from your question, it sounds like you're having this part's going okay, and then it's the figuring out how to write the answer in the right form that's hanging you up. So I did this part out ahead. I'll just talk real quick through what I did in case you had any troubles there. So I distributed the 3 on this line, and then I added that 3 over to this side to isolate the 12x, and then I'm dividing both sides by 12. And again, I think you got to hear same thing, distribute the 3 through to get this, subtract that 6 over. That got me that 12, and I divided both sides by 12 to get the 1. So that's the algebra to get down to the spot where we got to do that interval notation. So on this side, this would read x is less than negative 2, and over here we have x is greater than or equal to 1. So the interval notation to me is the hard part. Even if I don't have to, even if I didn't have to draw the graph, if you're new at it, I would tell you to draw the graph because the graph is actually pretty helpful for getting to the interval notation. So for this endpoint, we have this less than, and let me just remind you over here, when we have less thans or greater thans, that's going to be an open dot, and in our interval notation, that's going to be a parenthesis. When we have less than equal to, greater than equal to, in other words, with the equals to, those ones on the graph are going to have a solid dot and brackets. I'm actually not on camera. I have a person being sneaky behind me. It's just audio, so they do know we're doing this much at least. Okay, I'm back. So no equal sign, open dot, always parentheses, equal sign, solid dot, and then that gets brackets. And then in terms of the infinities are always going to be parentheses. So if there's an infinity involved, no bracket, that end is going to be a parenthesis. Okay, so with that, come over here and we got this x is less than negative 2. Okay, so no equals, so that's going to be an open dot. Less than negative 2 is this way. In the event, I remember being a student and having such a hard time with this. In the event, like which one is that less than greater than, which way do I draw it? Check it out. The arrow goes the same way as the inequality. So if you had thought of that little inequality as an arrow, it's telling you which way to draw it. Same thing over here, x is greater than. So that tells you, if you think of that as your little arrow, it's going to go this way. So x is greater than or equal to 1. And because of the equals to, we got a solid dot right there. And then we would be going out this way. So if I think about what this would be in terms of interval notation then, this is going forever to the left. Out here lives negative infinity. This is going forever to the right. Out here lives positive infinity. So that means in terms of my endpoints, I'm starting from negative infinity. We always start on the farthest to the left, and then we work left to right. So going from negative infinity, and we're going up to this negative 2. And then that's an open dot. There's no equals, so that's a parenthesis. Anytime we have a gap like that, we're using a union symbol to bridge the gap. And then I have the solid dot right here, so that means solid has an equal sign and it goes with a bracket. So the bracket would be 1, and then this goes on out to infinity. And that's the show for that. So for me, having this picture in front of me helps me get things in the right order, which is where I see most people having the trouble. So if you sketch the graph, hopefully that will help to do this piece. I'm going to erase this and just do a couple more quick examples. Oh, I should just do this the easy way. Just do that and start fresh. Okay. Oops. There we go. So let's say we had x is less than or equal to 5, or x is greater than or equal to 7. So if that was our situation, we would have 5 here, we would have 7 there. These are both equals, so that would be a solid dot, and that would go this way. Solid dot, this would go this way. So the interval notation would go from negative infinity up to the 5, and then bracket that time because of the solid and equals, union 7, and then on out to infinity. So what if we had the other kind, the kind with the and? So if that were an and, I would need to go, if we had x is greater than 5 and x is less than or equal to 7. Let's say that was where we solved it out and we got this instead. So now if I try to draw that one, there's our 5, there's our 7. X is greater than 5, so that would be an open dot going that way. X is less than or equal to 7, that would be a closed dot. And again, if we think of which way those arrows would be facing, the 5 is going this way and the 7 is going this way. So that one is going to be in between the points. And so when we have an or, we get a graph that has these two branches going either direction. When we have an and, what we're looking for is the intersection, the place where the two graphs would overlap. So you're going to get kind of a closed interval like this. And so if this was my graph, then my interval notation would be from 5, parenthesis because of the no equals, and then up to 7, bracket because of the equals. Hopefully that helps out, sort out some of the interval notation questions.